All right, so this is us talking about the D and F blocks, and with full electron notation and orbital notation. The D and the F blocks are a little bit different than the S and the P, and we'll see that here as we go. All right, so here's our friendly neighborhood periodic table. So what you got to remember is we have the first two columns on the table are the S block, and these ones over here are the P block. Okay. The other thing we have to remember is all the rows on the periodic table are numbered. We have 1, 2, 3, 4, 5, 6, 7. Okay? These are the energy level, the primary energy numbers. We also refer to those as N. Okay? And the other part to remember is this stuff down here, these ones right here, they're actually supposed to be in the periodic table. That's what these little weird little symbols are right here. So this row is supposed to fit in right there, and this row is supposed to fit in right there. So don't forget that. We'll come back to that in a second. Okay. So we have the S block and the P block, and those are the same thing we've been using before. So if it's in the one, something beryllium is in the S block, it's in the 2, and it's 2 spaces over, so beryllium would be 2, would end on 2s2. You know that because it's in the S block, it's in the second row, and the second one in. Just like sulfur is in the P block, it's in the third row, and it's 1, 2, 3, 4, so you know that sulfur ends on 3p4. Okay, so we say that S, the energy level that S is in, is equal to N. Okay, so the number for that is the same as the average, or the row number for the table. Okay, so there's two other blocks though on this table that we haven't talked about. We have this one right here, and this is the D block. And then down here we have this one, which is the F block. Okay, so the D and the F block are different. First off, while the S block has 1 orbital, so it can hold 2 electrons, and the P block has 6 orbitals, 1, 2, 3, 4, 5, 6, or sorry, has 6 orbitals, 1, 2, 3, 4, it has, wow, 1, 2, 3, 4, 5, 6, has 6, can hold 6 electrons because it has 3 orbitals, so it's 6 electrons. The D block, you can even count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's got 10. It can hold 10 electrons, which means when we draw it, it has 5 orbitals. So, 1, 2, 3, 4, 5. Okay. So the other thing that's weird is while the S and the P blocks are the exact same thing as the number of the row, the D block is different. The D block, and we'll go over this in the next couple of slides why, but the D block is equal to N minus 1. That means the row number N minus 1 is the block. So this one, so this goes in like right here. This is in the 4th block. Okay, the 4th row in the D block. Okay, so this is going to be a D orbital, or the D orbital, but it is D is equal to N minus 1. So this is 4s1, this is 4s2. This is not 4D, nor is it 4P. It is 3D, and this one's going to be 3D1, 3D2, 3D3. And then here, yttrium, this one is in the 5th row. This is how it goes. N minus 1, so this is 4D. And this row is going to be 5D, and this row is going to be 6D. See how that works? It's the row number minus 1. Now the F block is a little bit different. The F block is equal to N minus 2. Okay, so that means it's the row number that's in minus 2. So the F, you remember, is in the first part. So the F can hold 14 electrons. You can always remember that by just counting how many things are in this row. So they can hold 14 electrons, and it's N minus 2. So that means this first one, lanthanum, is in row 6. So this is actually 6 minus 2 is 4. So this is 4F1, 4F2, 4F3, etc. And the next row is going to be, it's in row 7, so 7 minus 2 is 5, so this is 5F1. 1, 5, F2. So that's how the D and the F blocks work. S and N are S and P are easy because they're the same as the row number. D is the row number minus 1, and F is the row number minus 2. So we'll go over this a little bit more. Okay, so just a quick review for the D block. Remember, the D block fills one energy level lower, so that's the N minus 1. So it's whatever the energy level is the same as the row number. Okay, so fourth row is 3D, fifth row is 4D, sixth row is 5D. I always want to say 5D. Okay, so this is because these nature's not nice and clean as we'd like to think. So the 1s is the lowest energy level, 2s is the second lowest, 2p, and 3s and 3p like we've done, and then we've gone to 4s. But the 3d energy level is actually higher energy level than the 4s. So remember, electrons, think of it like afraid of heights. Electrons don't want to go any higher than they have to. So because the 4s, which is that nice little round shape thing, is lower energy than 3d, the electrons actually fill in the 4s before they fill the 3D. That's how that looks on this energy graph. So let's talk about bromine. Bromine's number 35 on the periodic table. It's actually in the P or P shell, and it ends in 4p5. So it means we're filling this all the way up to here. So I just want to show you how it works. It's pretty straightforward. 1s1, 1s2, 2s1, 2s2, 2p1, 2, 3, 4, 5, 6. Remember Hund's rule, it fills 1, 1, 1, and then goes back. 3s1, 3s2, 3p1, 2, 3, 4, 5, 6. Then it goes to the 4s1, 2, and then it goes to 3d, and still follows Hund's rule, so 1, 2, 3, 4, 5, and then back, 1, 2, 3, 4, 5, for a total of 10, and then finally, remember, it ends on 4p5, so we go 1, 2, 3, 4, 5, and there's bromine. It's long. I know it's long. I'll show you a shortcut later, but for right now, we're going to deal with the long one. Remember, if we wanted to draw this out, it'd be 1s, 2s, 2p, 1, 2, 3, 3s, 3p, 4s, then 3d, 1, 2, 3, 4, 5, and then 4p, 1, 2, 3, and we put the electrons in 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5. So yes, that's ridiculously long, but that's how, if we took this whole thing here and wrote it out, that's what it would look like. Okay. So here's this little picture. I like this little picture. Remember, S block, which is equal to N, 1, 2, 3, 4, 5, 6. P block is equal to N. And then finally our D block, which is N minus 1. So the row number minus 1. So once again, because of this, if you can remember the blocks, the S, P, and D, you can remember that S and P are equal to the row number and D is N minus 1. You can know where any element ends just by, like the last part of its electron configuration, just by looking at the periodic table. You can know if you end right here, 1, 2, 3, 4, 5, 6, 7, it's going to end in 3D7, and then you just write all the other numbers up to that point. It's really easy. Let's do a couple. All right, calcium. This is going to take forever. Calcium is right here. So that is in the S block, and it's in row 1, 2, 3, 4. So we know that we're ending in 4s, and the second one over 4s2. So this is kind of our basis. We're not even using our D block here. So we have 1s, 2s, 2p, 3s, 3p, 4s, and then we don't even need the 5D blocks. So we're not going to leave this blank, but we know we're going to 4s2. So we're ending here. Boom, we're done with that. Then we just put in arrows. That's a lot of arrows, right? Oh, it's going to get crazier, I promise. And if we wanted to write the electron configuration, remember this would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Boom. Okay, easy peasy. So let's do something. Iron. Iron is right here. So iron is our first one in the D block, and it's 1, 2, 3, 4, 5, 6 spaces over. So that tells us we're going to end on 3D6. It's in the fourth row, so it's n minus 1. It's in the D block in the center, so it's D, and then it's 6 spaces over, so it's 3D6. So it'll be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So that tells us now we're just going there. So let me do the arrows, right? It's really easy. So let's do the D blocks, then the rest of them is just up and down. 1, 2, 3, 4, 5, 6. That's a crappy looking. I'll try that better. There's our 3d6, and the rest, that means we're just doing the correct number of arrows for each one of these. That makes sense? So 1, the D block is n minus 1. I'm not even going to do copper. Copper is just 2 more over, or 3 more over. So look, it's ending right there. So that means it ends in 3D9, right? Because it's right there, 3D9. So it means it's going to look exactly the same, except right here it's going to be 3D, instead of being 3D6, it's going to be 3D9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And the rest of it's going to be exactly the same. I'm just trying to make this video not so long. Alright. Oh, look, I already drew them out. Ha! Check your work. Alright. So the F block. This periodic table, I want to point this out. Like I said, the F block is N. This is the F block right here. Do you see what this does, the table? It makes it huge. That's stupid. It doesn't fit on the wall. I like to have my posters be able to nicely fit on a wall. So scientists said, like, well, you know what, all these, we don't actually mind them that much. So we're going to take these bad boys and we're going to cut them out and we're going to put them down here. And hey, look, it'll close up the periodic table and everything will fit. Yay! So you got to remember, the F block fits in 2 energy levels lower than it appears on the table. So this is row 1, 2, 3, 4, 5, 6, 7. It is n minus 2. So this is in row 6. So this is going to be 6 minus 2 is 4f, and f can hold up to 14 eventually. That one's going to be 4f1 though. And this next row is in row 7, so this is 5f, and then all the numbers that go with it. Again, this is because here is lithium, which is in the F14. Ooh, that sounds like a plane, right? 14. And again, let's just show you. See, you have the 1s, you have the s orbital, and you have the 2 energy level. Those are easy. But then 3, you know, we have our 3 P's, and it skips to get to 3D. And then the 4 comes in, and the 4s is before the 4D, and then the 4P. But then 5s is even lower energy before we get back to 4D, before we get back to 5P, before we eventually get to 6s, and then finally 4F, which is way high up here. See how it's connected to all of them. So the biggest thing to understand is the further up, the further you get away from the element, the center of the atom, which is what's happening here, stuff starts to kind of overlap. And that's what determines a lot of the properties of these elements. Okay, so don't forget to sum this up. Row numbers, which is n, 1, 2, 3, 4, 5, 6, 7. Okay, the S block is everything here, and remember that is, the S block is n minus n. It's just n, no minus. Okay, you have the P block, which is also n, so it's just the row number. The D block, which is n minus 1, and the F block, which is n minus 2. The row number, remember the row number is n. Okay? So, another way to do this is off-bow diagram. I like showing this. It's like Chutes and Ladders. You can find this. If it's one of those ones, if you can't remember exactly how it goes, it's pretty straightforward. You go to the 1s, you go to the next arrow. So after 1s is 2s, After 2s is 2p. You just follow the arrow down. 3s, after 3s is 3p. 3p goes to 4s, 4s goes to 3d, then to 4p, then to 5s. And so if you can look at the periodic table and figure out where your endpoint is, you know it's in here. Like, you know, if you can say like, all right, it's in row 3, it's in row 5, and it's in the p block. I know I got to keep filling this until I get to 5p. You can use. I actually remember taking a test in college where I wrote this on the side of my test to help me be able to fill these out. So you just got to remember that technically, you know, the first energy level's got 1, it's got one thing, 2, it's got 2, 3, it's got 3, 4, it's got 4. We haven't actually discovered these yet. We've got no elements that need them, but you know, you never know. We'll see what happens. Okay. So let's do one together. One ridiculously long one. So we're going to do lead. Lead is right here on the table. It got 82 electrons. We're going to be writing a lot here. So let's look. We're clearly in the p block, right? So we're going to p, and we're in row 1, 2, 3, 4, 5, 6. We're in row 6. So we're ending on 3 or 6 p, and we're 2 spaces over 2. So we're ending on 6p2, but we have to fill in everything else up until that point. So let's do this thing. Okay, we have our S block, we have our P block, we have our D block. So we start with S block, so 1s2. Okay, good. Now we're here, 2s2. Boom. Fill in 2p6. Boom. Next, 3s2. Boom. 3p6. Boom. Next, 4s2. Boom. All right, now we go to D, and remember that D is n minus 1, so this is 3D. So 3D, we're doing all of it. 10. Boom. And we're back to our nice simple P block, which is the same as the row. So row 4, so 4p6. Boom. Go to 5. So now we're at 5s2. Boom. Back to our D block. We're in row 5, so n minus 1. So our D block is going to be 4D. We know we're going all the way across it. So 4D 10. Boom. Okay. Keep going. Back into the P block, so 5p6. Boom. All right. 6s2. Boom. Now we're into this is part of the F block, and we're doing all the way across the F block, so it ends up being the row number 6 minus 2, which is so 4F, and it's going to be 14 because we're all of it. Then we're back to the D block. Yay! Except D block is the row number minus 1, so we're in row 6, so 6 minus 1 is 5D10. Boom, and we finally almost reach lead, so we're getting to the point where we're trying to reach it, so it's going to be 6p2. We're done with the electron configuration. We could draw the arrows for that. I'm not going to, but you know, it's just still going to be the 1s with the arrow. I just got to remember, you're just doing you're doing 82 arrows. Let's avoid drawing 82 arrows right now. So, big things to pull from this. The D block can hold 10 electrons, so it has 5 orbitals. If you have to draw, that's a 5. I promise it's a 5. No, not an S. 5 orbitals, which means, you know, the little lines 1, 2, 3, 4, 5. Okay, and it is the energy level n minus 1. Okay, and we remember that the F block can hold 14 electrons, which means it has 7 orbitals if you had to draw it. Okay, and its number is n minus 2. So right now we've only discovered 4F and 5F. We have nothing beyond that. So there you go. Hope that made sense.